Hello everyone, welcome back to our channel Mathematics and Beyond, and today we are going to do a very interesting chapter of class 8, which is a chapter number 2, Exponents and Powers. So let's get started with its chapter's introduction. So a number which is multiplied many times by itself, it can be written in exponents or power form. So any number a raised to the power n is equal to a into a into a into a n times. So to understand this chapter's introduction very nicely, we are going to take an example, which is 5 raised to the power 4, where 5 is the base and 4 is the exponent. So here also, as you can see in this image, the 2 is base, exponent is 4, and this whole notation or this whole number is known as exponential notation. So another example is minus 4 into minus 4 into minus 4 is equal to minus 4 raised to the power 3, where base is minus 4 and exponent is 3. Now let's move further with the laws of exponents. So if a and b are real numbers and m and n are integers, then the following rules or laws would be applied. The first very law is product law. When the bases of two numbers are same and we multiply them, their powers are added. So a raised to the power m into a raised to the power n is equal to a raised to the power m plus n. Second law is quotient law. When the bases of two numbers are same and we divide them, their powers are subtracted. So a raised to the power m by a raised to the power n is equal to a raised to the power m minus n. Now a third law is power law. When a number in exponential notation is raised to another power, the powers are multiplied. So a raised to the power m, and outside the bracket it is n. So both the numbers m and n will get multiplied. So the result would be a raised to the power m into n. Now fourth law is zero exponent. So any number raised to the power 0 will give the result as 1, where a is not equal to 0. Now fifth law is negative exponent. So any number a raised to the power any negative exponent, here we have taken minus 1, then it is equal to 1 by a. For bringing it in the positive form, we will reciprocal the whole number. Now our sixth law is power of question. So a by b raised to the power m is equal to a raised to the power m by a b raised to the power m. So in which what we have done in this law. So previously it was a by b raised whole raised to the power m. So you have to check this. It is whole raised to the power m. Now we have divided it into two parts. Then it is a raised to the power m by b raised to the power m. Now our seventh law is a by b raised to the power minus 1 is equal to b by a. So this is a bit similar to our fifth law. What we have done in this part, we have reciprocal the whole number to bring it in a positive form. So now our eighth law is the power of product of two numbers. So this law is also similar to our sixth law, but in this law we have multiplied. So a into b raised to the power m is equal to a raised to the power m into b raised to the power m. So now let's move further with very important note. You have to keep this in mind that for all non-zero rational numbers a and all positive integers m and n, 1, if m is equal to n, then a raised to the power m divided by a raised to the power n is equal to 1. Now second, if m is greater than n, then a raised to the power m divided by a raised to the power n is equal to a raised to the power m minus n. Third, if m is smaller than n, then a raised to the power m divided by a raised to the power n is equal to 1 by a raised to the power n minus m. Why we have done this? Because to bring it in a positive form. Now let's move further with a very important topic, which is the last topic of this chapter. It is standard notation. So standard notation is basically used to represent large numbers that occur in a scientific study in a convenient way. It also saves the effort of counting many trailing zeros in large numbers. So you have seen that in science or in any other study, we have seen there are many zeros. So to avoid them, we are using this standard notation. Standard notation is also known as scientific notation. So a number in standard notation can be written as a product of a decimal number from 1.0 to 10, but 10 is not included. It is only till 9. So now next, a power of 10. So we are done with that chapter number 2 of class 8. So I hope you all liked it, but we are going to discuss a very interesting fact, which is there are many types of interesting numbers in mathematics. So one such number is 100. The number 100 does not actually mean 100. It is derived from the Old Norse word, which is 100, which actually means 120. So now we are done. So thank you everyone for watching this video. I hope you all liked it and please subscribe to our channel. Thank you for watching. Bye bye. Also share it.